Okay, well, I would have to start with quantum mechanics.
Uh-huh.
And I think it's important for people to understand quantum mechanics better because there's a part of quantum mechanics that's very much publicized that has to do with the Copenhagen interpretation and how, an observer or observation has to happen before the material world materialize in what it is and all this. And
so this is the observer effect, where they showed that if you're looking for particles, you'll see particles. If you're looking for waves, you'll see waves, which then allowed people to say, the reality is dependent upon the observer's intention.
That's right. And that interpretation is known as the Copenhagen interpretation. It comes from a very famous conference that occurred there. And this interpretation, I believe, is completely incorrect. It's completely false.
All right. Shots fired right out of the gate. Okay.
And it's really important for people to know. And actually, students in physics should be taught that. For some reason, they're not. That there's alternative views that were given by very serious people, de Broglie being one, and Bohm, and that give all the correct answers with a very mechanical fluid dynamics view of the effect. And in that case, you don't have to invent really, esoteric, ungrounded ideas that somehow particles can be waves and particles at the same time. And it basically, the only difference in the interpretation is to show that actually when a particle moves, it's moving in a field. So when it moves, it makes waves, just like a boat on the ocean. So it's a particle and a wave. Yes, but not in some esoteric way. It's just when it moves, it makes waves in the field because it's not in a field-free environment. Space is a field of energy. And actually, I demonstrate very clearly that it is the field of energy that makes the particle in the first place. So, of course, okay, so we can get into the double slit experiment, which is how this interpretation occurred. But I'm going to have to back up to the foundation of mechanics, of quantum mechanics.
I'll let you drive the ship here.
So if we want to talk about the double slit experiment, we can do that. I'm just going to give it quick interpretation. It's called pilot wave theory. And it just shows that, okay, so the experiment is like you got one slit and you're shooting electrons or photons at this slit and you have a detector on the back, right? And you expect on the detector, you're going to get dots for each particle that hits the back detector, and the ones that hit in front of it won't be detected, right? The ones that don't go through the slit. But then you put two slits, and you'd expect that you'd get some particles going through the one slit and some particle going through the second slit, and you should have like dots on the backboard, right? On both sides, on both slits. But instead, you get an interference pattern, okay? And that was weird because it's like, what's interfering with the particle? So then it's like, oh, the particle is like becoming two particles going through both slits and interfering with itself. And like all this, like, I don't know what they were smoking, but it wasn't the good stuff. It's a very strange interpretation. Sure. And then, of course, scientists at the time tried to like measure exactly which slit did the particle go through. And how is it that it's interfering with itself? And when they tried to put a measurement instrument there, they realized that when they put it there, all of a sudden they get dots on the backboard, so it changes the result. So then the interpretation is, oh my God, when we try to measure it, which we have to make the distinction. That doesn't mean there's a conscious observation. Could be a measurement from a device that's just tied to a computer, nobody's looking, right? But when we try to measure it, we get a different result. And this led to a series of equations that describe this collapse of the wave function, of the quantum wave function that makes up particles. But if you take the analogy of the boat on the ocean, And when the particle is moving, it makes waves. Well, then when you have one slit, you get the dot because only the boat goes through. When you get, I'm saying this loosely, right?
Yeah.
Just so we understand, like it's more in depth than that. But and if you look up pilot wave theory, you'll get all the information. But if you have two slits, then the waves that the particle made go through the second slit and interfere with the particle and produce an interference pattern. And then if you put an object to measure what's going on there, if you add a measuring object, that object is making waves in the field. Mm-hmm. And it's canceling the waves that the particle is making. Mm-hmm. And now you get a third result. Mm-hmm. But it's not some esoteric thing that like there's an observation and it's changing. It's just a fact that everything is bathing in a fundamental field of energy that interacts with all things, mm-hmm. that connects all things.